Hello, and welcome to this training video about superstrings within solar panel systems. Today we'll discuss the risks presented by superstrings, how a superstring is created and how to prevent them, and then what to do in case you suspect one has been created. This video is for anyone involved in either the construction or maintenance of solar DC systems, to include activities such as plugging in MC4 connections, repairing harnesses, initial construction and commissioning, and also operations. A superstring occurs when too many solar panels are connected together in series, which creates an overvoltage condition. Such a condition increases the risk of electric shock to employees and could also cause equipment failures, which can lead to potential fires. Superstring conditions are a common problem in the industry, and companies can experience several such events if precautions are not taken to avoid them, which goes to highlight the importance of implementing and following a strong prevention program. Let's see how a superstring can be created. First, we'll look at a normal circuit of 6 solar panels that are connected in series. Each panel produces a nominal voltage, and in this example, it's 250 volts DC, or direct current, per panel. In electrical circuits, the voltage increases as panels are connected in series. The more panels connected in series, the higher the voltage increases. In this case, 6 panels connected in series increases the voltage to 1,500 volts DC. This is commonly referred to as a string, and this example of 6 panels is considered a typical solar string, although some designs can call for more than 6 panels per string, so it's crucial to know what the nominal design is at your park. In each row of solar panels, there are multiple strings, each totaling 1,500 volts DC. These strings are then connected together in a parallel circuit. When an electrical circuit is connected in parallel, the voltage does not increase, but the current, or amperage, does increase. That's why the voltage of the entire system should never be any higher than 1,500 volts DC. Keep in mind, a superstring condition is created when more than 6 panels are connected together in series. Whenever the voltage increases beyond 1,500 volts DC, it exceeds the design rating of all the components in that system. One such example took place where 84 solar panels were connected together in series, when the design called for only 6 in a single string. This increased the voltage to over 20,000 volts DC, which was nearly 14 times higher than the system's design voltage rating. When the system voltage exceeds its designed rating, the risk of fire and electric shock increases dramatically. In this case, the technician working on the system unfortunately received an electrical shock when he attempted to plug in the last connector to the harness. The electricity arced through the air from the plug to the employee's bare hand, down through his body, and exited out his foot to the earth, causing an injury. Your company should have a defined procedure to ensure solar panels are connected together correctly, with clear instructions on how to prevent a superstring from occurring. Some of these preventative measures could include the following. While laying out the wiring, use zip ties to secure the connectors in place and dress the wiring in advance. The zip ties can hold the MC4 plugs in position to correlate them with the appropriate harness plug that they'll eventually be connected to. Place flags or ribbon at the start and end of each string as a visual control for technicians to know where to stop connecting the panels together in series and to connect the completed string to the harness in parallel. Perform a quality check of the entire row to inspect the dressed connectors for proper layout prior to assembly. Have technicians start on opposite ends when connecting a long row of panels together. If the technicians meet in the middle of the row and find they have a mismatch, it could indicate that the strings are not connected properly. If it's discovered that a superstring has been created, stop work immediately. Do not unplug the MC4 connectors or even touch them. As previously stated, the voltage is likely exceeding the design rating. Next, determine how many panels are connected together in series. Then, notify the safety team, site leadership, and the engineering department for guidance. You may need to develop a plan to unplug panels overnight. Once the sun goes down, the voltage of the system drops to a safe working level, which reduces the risk of electric shock. Using solar panel covers is a new concept that is still in testing, but could prove to be effective to eliminate or at least reduce the voltage down to a safe level. Also, please note that any time a superstring has occurred, the components involved have been exposed to an over-voltage event, and therefore all equipment will need to be evaluated by engineering experts to determine if the components are damaged and require replacement. Because solar systems operate at 1,500 volts DC, handling MC4 connectors, harnesses, and even panels will always present the hazard of an electric shock to employees. Even though many MC4 manufacturers state that their connectors are touch safe, that statement only applies when the connector is factory new and has not been exposed to elements in the environment or any other potential damage. This especially applies if an overvoltage condition is present because a superstring has been created. That's why it's required. Rubber-insulated shock protection gloves are always worn, and never touch connectors barehanded. Also, remember to air test your gloves prior to each use and visually inspect them to be sure they are in good condition and within the test date. To summarize, follow your company's guidelines to prevent a superstring from occurring. Make sure you understand how many panels the design calls for in a single string. If you suspect a superstring has been created, handle it safely by stopping work and notifying the appropriate personnel. Do not unplug a connector that is suspected to be in an overvoltage condition. Be sure to protect yourself from shock hazards by wearing the proper PPE, such as shock protection gloves, and by following procedures. Thanks for your attention. If you have any questions, please reach out to the safety department for further guidance.